Welcome everyone. Welcome to this computer architecture course. And then I found many students are here. Okay, so this is the first day of the spring semester, but we encounter blizzard. Okay, so the weather is just so beautiful, right? Okay, so I will briefly introduce about this course, right? This is the computer architecture course, and then the university has changed the Blackboard system. So now I'm learning learning about this Blackboard system. So actually in the previous semester I utilized the Blackboard, the different Blackboard system, but the university changed this LMS system, the learning management system. So now I'm learning. So actually, so I will briefly introduce about the this course, right? So so this course is the computer architecture course, So this is the mandatory course in computer engineering department. So why is this mandatory course? So it is because it's important. Okay. So I believe most of you are computer engineering or computer science student. So maybe your department can be data science or some other department, but I believe everyone everyone is interested in sorry, the computer engineering field, right? So in the computer engineering department, we learn about the computers, right? Obviously, right? Then what does that mean? Then some of you may think that, so in the computer engineering department, you can learn about the programming languages, right? But actually it's not true, right? It's just language, okay? So actually in the computer engineering department, we teach about the computer systems and how to use computer systems, right? How to use includes programming languages, right? So you can also learn about the programming language course or some high level course such as the AI, artificial intelligence, or deep learning. But actually in this department, you need to learn about the computer systems and how to use computer systems. So I believe everyone knows the computer system is composed of hardware part and software part. And then we usually use software part because normal users just use applications. Applications are software, right? But under this software layer, there is a hardware layer. So so everyone knows that. I believe everyone knows software runs on the hardware or hardware computer system. So that's why you need to know about the hardware computer system, because the software runs on this hardware, and then in order to run software more efficiently, so I said more efficiently, so you need to understand about this hardware system. That's why, so you need to learn about the computer architecture course, right? So let's see the object of this course, right? So, okay, I can write. So what is the object of this course? So in this course, we will explore computer system architecture. So same word, but at an abstraction level, okay? So we will learn about the concept of abstraction. So maybe in the next class. So actually, the computer systems are very complicated systems, right? And then in order to learn about these complex systems, we need to simplify because this is very difficult. It's very difficult to understand. Also, it's very complicated. So we need to simplify. We need to simplify the systems. So actually think about the software. So you don't need to understand about the actually computer system, right? So you can just use applications on the mobile phone or on your laptop, right? So you don't need actually you don't need to understand about the computer system in order to use your applications. It's kind of abstraction because you don't need to understand about the complex computer systems, but we can use software, right? We can use computers, right? So, but in this course, we will learn about the computer architecture. So at a certain abstraction level. It's a different abstraction level. So we will focus on the hardware systems and the software hardware interfaces in the computer systems, right? So what will be covered in this course? So we will learn about the basic concepts of computer systems, right? And then this course will include the performance metrics. So we need to learn how to measure the performance of the target computer systems, right? So it is because everyone wants to buy good computers, right? Or better computers. It means it's a faster computer or energy efficient computers, right? So we will learn about the performance metrics first, and then we will learn. So these are three major topics we will cover in this course. So instruction set architecture, it is called ISA, okay? So, so we, so as I mentioned, so these are three the main topics we will learn in this course: the instruction set architecture, and then another process architecture. It's called pipelining, and then memory hierarchy. So in the end of the semester, then if you take this course, then you need to understand about the instruction set architecture and then basic process architecture such as pipeline architecture and memory hierarchy. Okay, so these are three main topics which will be covered in this course, right? So we will learn about the instruction set architecture and machine languages such as the assembly languages, right? And then so this is just to review the arithmetic logic and number systems. So if you took the digital logic design course, then I believe you already learned about this arithmetic logic and number systems, but it's just a review, okay? And then we will learn about the process architecture. So we will learn how to organize CPUs, how to design CPU components, okay? But it's a very simplified version. So actually, so we we usually use x86 CPUs such as made by Intel or AMD. Also, we can use the mobile CPUs such as Exynos or Snapdragon, made by Qualcomm or Samsung. But so these processors has very complex structures, right? But in this course, we will learn about the very simple and the simple and it's old style design. Okay, so actually the modern processors includes the very complex structures, but in this course we will learn about some basic approach, basic design approach of the processor architecture. Okay, and memory hierarchy. So memory is just so important in the computer systems. Why? So what is a computer? So computer is a machine that processes data. Right. It's just a definition of a computer system. Okay. A computer can manipulate so the processes our data. But this data is in the memory. Okay. So the performance of memory systems such as the DRAM or SSD, the storage devices. Also, the CPU includes the on-chip memory, right? So actually, the performance of memory systems is very critical. It's very critical for the performance of a computer system. That's why we need to learn about the memory hierarchy. So that's how the memory system is organized. So we will learn how the memory system is organized in a computer system. And then if we have time, then we will learn about the parallel processor architecture. Okay. But just to remember that these are three main topics: ISA, instruction set architecture, and then process architecture, it's a pipelining, and memory hierarchy. Okay, so we will use this textbook, so Computer Organization and Design and RISC-V edition. So we will use the second edition, and then this textbook is written by David Patterson and John Hennessy. So they are legendary researchers. They are legendary researchers in computer architecture field. Okay, and then this textbook is very popular, and then most universities use this textbook for teaching computer architecture course. Okay, but we will learn about the RISC-V edition. Okay, and then in this course, I will use the lecture slides, and then so I already posted the two lecture slide decks, right, on the LMS. So learning on LMS, the learning management systems. So I will post the lecture slides before when I use this lecture slide in the lectures. Okay, so you can download the lecture slides before the class starts. Okay, and then this is not a compiler course. Okay, but so actually, so in order to understand the instruction set architecture, then we need to use a compiler. Okay, compiler is a translator. So compiler translate our high-level language code into the machine code, okay, machine languages. So, and then so as I mentioned, we will learn about the instruction set architecture. Okay, so then we will use C or C++ compiler for compiling our high-level language code. So actually, I will provide some lab materials for practicing this compiler, okay, compilers. And then actually, in order to understand the process architecture, the best way to understand this process architecture is to design your own processors, right? So that's why, so we have some several design labs for process architecture. Okay, so we will use several simulation tools that run on the Linux operating system or Mac OS. Okay, so we will use the simulation tools, and then I will just introduce the architecture simulators. Okay, okay, and then if you so you know this is the English course, right? So I will primarily use English during the lectures. Okay, and then also the textbook is written in English. But if you have some trouble to understand these English lectures or English books, then you can purchase this book. It's written in Korean. Okay, also this book is written by 서태원 교수님. So okay, in the same department. Okay, so if you want to read the computer architecture textbook in Korean, then you can purchase this book. Okay. Also, I used this book, Digital Design and Computer Architecture for digital logic design course. But this book also includes some computer architecture topics. Okay, so if you are interested, then you can read the computer architecture topics in this digital design and computer architecture book. Okay, so these are additional material. So if you are interested, then you can read these books. So actually, reading is so important. So right. So I found that in the previous semesters, the many students did not buy textbook, and then they just attended the lectures, and then they just watched some recorded YouTube video, and then they watched they just read the lecture slides. But so actually lectures, my lectures cannot include every topic in the textbook. Okay, so if you want to understand the computer architecture topics thoroughly, then you need to read. You need to read some books. Okay, you need to read some chapters, or you need to read some reading materials. So actually, this is very important for your study, and then for your research. If your career goal is related to the research area, then reading research material or reading some textbook is so important. Okay. So I know. So this actually this book is not cheap, but I recommend you to purchase the textbook and try to read the textbook. Okay, this is very important. Okay, so they are authors. Okay, so David Patterson and John Hennessy. Okay, so as I mentioned, they are legendary researchers. Okay, and then recently, so it's when they were young. So this is the photo, and then so it's a recent photo. Okay, so also they are responsible Turing Award. So Turing Award is kind of it's similar to Nobel Prize in computer research, computer science or computer engineering research. So actually they received the Turing Awards in 2018. Okay, and then they provide the Turing lecture. Okay, so this lecture is a very popular lecture. Okay, so if you are interested, then you can click this video link, and then you can watch the Turing lecture provided by David Patterson and John Hennessy. Okay. So this is the prerequisite of this course. So so actually I expect that the students took digital logic design course. So it is because actually, so in this course, I will provide several design labs. And then in these design labs, you need to use HDL, like hardware description language. So we will use system Verilog, right? And then, but in this course, I will not teach about the system Verilog. So we don't have enough time. Okay, so I will just provide some materials for learning system value, but I will not teach. Okay, so prerequisite is a digital logic design. Okay, it's required for the processor design labs. Okay, because we will use system value, and then we will use the simulation tool such as Icarus Verilog. Okay, and I just expect that you have basic knowledge on computer programming languages such as C or C++, not Python. Because the Python is is the very high level language, but the C is actually the C is designed for writing Unix operating system, right? So actually the using with uh, using C, that we can manage some system components. Okay, so in this course, I will just show some C example code, but it's very simple. So you don't need to understand some very difficult concept of C or C++ for this course, but actually you need to understand about some very simple C code. Okay, and then also we will you we will have some labs to you need to use the compiler, which means that you need to understand how to you need to understand some C syntaxes and then C code. Okay, not to practice the compilers. Okay. Okay, and then basic knowledge on how to use CLI. So CLI means a command line interface. So, so I believe you are very familiar with the GUI, the graphics user interface. But in this course, actually, both in the design labs, so we will use Linux operating system, and then in order to use the Linux operating system, you need to just use the command line interface. It's not graphical interface. You need to just input some commands or some uh, binary file names, right, in order to run some programs in the Linux operating system. So you need to be familiar with the command line interface because we will use the tools that run on a Linux operating system. Okay, so those are prerequisites for this course. Okay. Okay, about me. So my name is Konje Pu, Kugonje. Okay. And then this is my office. So Jongjongbogan 43. And then so if you are interested, you can visit my lab homepage. Okay. And then my research area is computer architecture generally. And then those are my research interest. And then there are two TAs, actually two TAs, Jung Chan-hun and Kim Nam-hun, okay? But so TA's roles are grading homework and lab assignment and exams. So they just focus on grading, okay? And then also they will answer your questions on Piazza. So I will introduce about the Piazza later, okay? So do not email TAs regarding homework and lab assignment. Okay, do not email. So I found so many students emailed TAs about some homework questions and then some other issues. But post your questions on Piazza. Okay, post on your questions on Piazza. Okay, I will introduce about the Piazza later. Okay, do not email. Okay, so about some attendance issues, email me, right? So TAs cannot handle attendance issues. Okay. For attendance issues, email me, and then some questions about the some homework or exams or design labs, then you need to post your questions on Piazza. Okay. 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 What is Piazza? So actually, the university provides the learning management system, but I do not trust this system. It's not convenient. Okay. So actually, I will use the LMS, the LMS system for posting uh, assignments and design labs, some quizzes or gradings. And then for Q&A, then we will use the Piazza. Okay, this is the uh, address of Piazza. Okay, and then you need to sign up as a student for this course. Okay, and then for sign up, you need access code. Access code is the Pasadena. Okay, it's the city name in US. Then please join as a student, and then this is actually we will use the Piazza as a discussion board. Okay, so I found the Blackboard no LMS includes the Q&A board, but so as I mentioned, it's not convenient. So I do not trust about this system. Okay, so anyone can post questions and answers. Okay. Also, there is a Piazza mobile app, so you can post any questions on this Piazza. And then my plan is, so if you get some endorsement from me, then you can get additional attendance score, attendance points. Okay. So sometimes I can endorse some students post, then you can get some bonus points. Okay, for this your answers or your questions. Your questions. Maybe if you ask some questions, or very critical questions, then I can endorse you. Okay. So please use Piazza, not email TAs or do not email me about some questions in the course or some homework. Okay. So this is the example of a Piazza. So you can find that many students can post questions like this, and then also TA can answer the the posted questions. Okay. Sorry. On Piazza, you can post the questions in Korean, right? So, so, so I can understand Korean and English, not Chinese. I can just understand the two languages, Korean and English. So you can just post your questions in Korean and English, Korean or English. Okay. And then, so you can also click the resource tab on the Piazza. Then you can find some lecture slides and then lecture videos. Okay. Usually uh, I post the lecture videos. So actually the lecture is recorded via Zoom. Okay, that's why I'm using Zoom. And then I need to encode. I need to encode the recorded video, and then I post this recorded video on YouTube. And then I just provide the link to the recorded video on Piazza. Okay, but so so sometimes it may be delayed. Okay, so just focus on these in-person lectures, right? So I found some students just relied on the recorded video because they can watch they they, they can watch the recorded YouTube video, so they did not focus on the in-person lectures. Okay. But it's not good. Okay, so just to focus on in-person lectures, and then for the recorded video, so you can use the recorded video some for reviewing some previous lectures. Okay, or so you can just use watch the recorded video for practicing exams. Okay, prepared to be prepared for the exams. Okay, attendance check. Oh, it's changed. so so actually, so as I mentioned, the university has changed the Blackboard system. So actually, in the previous semesters, I used the Blackboard for attendance checks, but it has changed. It's okay, okay. So actually, so I will try. So actually, for 2 weeks, for the first 2 weeks, I will not check the attendance, right? Because during this week, you can just change the registration, right? But I believe I need to test this system. Okay, so okay, so you are lucky. So oh, okay, I will. So where is this? On the LMS, so you can find the offline attendance. Okay, and then I will create the attendance check uh, link. Maybe it's called the link. Maybe where is it? Mm. Okay, are you sure? Hmm? Stop share, share, and then weekly learning share. So okay, so in the week one, so this is your weekly learning. Then you can find the syllabus here, so the document, and then introduction document, and then also I posted the homework. So this is just a survey. Then there and then actually 0 point is assigned to this homework. But I, as I mentioned, I need to test this Blackboard system, the new LMS system. So I just generate the homework, and then please submit your answers via the homework link. Okay. Okay. And then I will generate the where is the offline attendance? Scheduled time. What's this? Duration time. Okay. Start smart attendance. Send notification. Okay, 10 minutes. Okay. So I don't know about how the student check this attendance. So, but I believe you received a notification from LMS. So please install the mobile LMS app on your smartphones, right? And then so I believe this is the some uh, attendance check code. Okay, so try to uh, check your attendance, and then so okay, so attended. Okay, so I will check your attendance using this system. Okay, uh, and then I believe So even though I will not check the attendance during the 2 weeks, the first 2 weeks, but I will generate the attendance code on LMS, so on this system, and then try to check your attendance via this system. I will not manually check your attendance. Okay, I think it's a waste of time. Okay, but I need to check your attendance because it's low. It's just low. So I will use this self attendance check system. And so for every lecture, you need to check your attendance using LMS. Okay. So why is it important? So I will just close this share. So is it because you will get F if you miss more than 1/3 of classes. Okay, so if you miss more than 10 lectures, then you will get F. So this is just a rule, just a law from government. I don't know why, but so if you miss more than 10 classes, then you will get F. So please check your attendance, okay, on LMS. As I mentioned, we will not check your attendance manually, but sometimes we will take pop quizzes, okay? Pop quizzes can be taken accidentally. And then if your attendance check is mismatched with this pop quiz submission, then you will get penalty, okay? Please be honest, okay? Please be honest. Okay, so absence. So if you miss classes due to serious illnesses or flu or COVID-19 or some public events such as exams or army training, reserved army training, then you can request waiver of attendance using portal, KU portal, okay? And then please submit proofs, okay? Okay, so it's a logistics, and then it's a grading policy, but it's a tentative, and then exams. So we will take on-site exams, the midterm and final exams, and then so it's a closed book exams, and then no electric devices are allowed except basic calculators, okay? And then any cheating. So obviously, any cheating may result in an F. In this course, you can answer in Korean or English. Okay. So as I mentioned, I cannot understand any other languages. Assignment. So there will be 5 homework assignment after each chapter. And then, homework assignment is very important for preparing for the exams. Okay. And then there can be 6 design lab assignment. So, and 2 design labs, you can just, for 2 design labs, so you can practice uh, compiler and ISA simulator. Okay, so instruction set architecture simulator. And then for labs, for labs, then you will practice the processor design. Okay, and then this is the latest submission policy that we will apply. So we will apply 20% of a penalty for every 24 hours delay. So usually the deadline is around the 11:59 p.m. on a day. And then if you submit the the 1 minute after the deadline, then you will get 20% of penalty. Okay, for every 24 hours for 1 day. Then we will now accept the submission later than 48 hours. Okay, so 2 days from the submission deadline. Okay, this is the late submission rule, late submission policy. Okay. Okay, this is the tentative schedule. And then we will take the midterm exam on April 27th during the regular class time. So this time. And then we will take the final exam, the June 19th during the regular class time. Okay, just check this date on your calendar. Okay, and then class will be cancelled on May 1st and then May 6th. So Labor Day, so the official official holiday in South Korea. Okay. Okay, so any questions? so, so if you have any question, you can post your questions on Piazza, and then then you need to register Piazza as a student, right? Okay. Okay, so okay. uh, Okay, so I will briefly about this computer architecture course. Okay, so actually I just introduced about some logistics and then rules and policies in this course, and now so I will introduce about the computer architecture. Okay, so this is just the introductory lecture. Okay, so even though this is the first day of the semester, so I will just teach. Okay. Okay. What? So what is a computer architecture? So you can find that actually these are computers, but these are old style computers, right? So the first computer is the firstly developed by the first PC, is a personal computer developed by IBM, right? And then those two computers are developed by Apple, right? So old computers. So we can find that the computers includes monitors, right? Like monitors here, and then keyboards, and then you can find the mouse in this computer. Okay, so actually for the typical typical figure of the computers that you can just think that computer includes display, some monitors, and keyboard because we need to type some letters, and then some large boxes. Okay, so this is you can think that this is a computer, right? But you can also find the very weird looking computers, right? Like this. But we can think that also these devices are computers. Why? So you can find, so this is a smartphone and then smartwatch and smart speakers. But we can say that, these devices are also computers. Why? So what is different? So you may think that, these are typical, but it's old computers, old generation computers. So you can think that, computers includes keyboard, display, and the large box. But you can say that, these are computers, phone, watches, or watch, and speaker. But you can say, this is smartphone, smart, not on not an ordinary phone. This is a smart watch, smart speaker. What is different? Okay, so we will learn. So we can say that, oh, these are also computer systems. So you can watch, you can see. So this is the Google TPU. So TPU, Tensor Processing Unit, and then this is FPGA, and this is GPU. So we can say that these devices are also computers. Why? So actually, these devices include processors, okay? But it's somewhat different. So actually in this course, we will learn about the CPU, like Central Processing Unit. But actually, recently, these devices like TPU and GPU are more popular. So the NVIDIA stock price is much higher than the Intel or AMD stock prices. Why? GPU. GPUs are more popular than CPU. Actually, everyone wants to buy better GPUs, or right, for AI applications. But those processors are domain specific, so little bit different, little bit different from our conventional processing units like CPUs. But we can say that these are also computers, a little bit different, but those are also computers. Also, we can study on gigantic computer systems. What does that mean? What is, so this slide shows data centers, right? Data centers include many computers, and then these many computers are connected via networks, right? And then we can say that, oh, those are cloud infrastructures. This means we can use our mobile phone, but our programs, our mobile phone just provides some instructions or commands to the clouds, and then clouds run our applications, and then results are provided to our mobile phone. So we can just use this cloud infrastructure like our personal computer systems. So actually the computer architecture also includes this study on gigantic computer systems like cloud infrastructure. So computer architecture just covers so small devices like the mobile phone or Raspberry Pi, or electric devices such as the TV or speakers, the smart speakers. Also, it includes the conventional computer systems such as desktop or laptop computers. Also, it can include the research on data centers, data center architecture, or data cloud infrastructures, such as this large computer system. Okay, but what is a common part? Mobile phone, electric devices. So you can find the washing machines here, and then conventional computer systems such as laptops or desktops, and then large data center infrastructure. Common part is a processor. Okay. Then what is a processor? So I mentioned that a computer system is a machine that can process our data. Oh, this processor can process our data, but you can say that, oh, other chips such as uh, old generation television chips, TV chips, or old generation uh, chips, some processing chips can process our data. But what is different? Computer processor uses mm, oh, uses instruction. Okay, instructions. Okay, so, so in this course, so we will learn how a processor handles instructions. How a processor handles instructions for processing our data. Okay, so you can just understand that a computer can run instructions or a computer can execute instructions. Okay, so there are different domains in computer systems. So so as I mentioned, the computer architecture or computer systems includes so many different devices such as mobile phones or some very common electric devices or also conventional computer systems. Okay, computers are this pervasive. Okay, so there are different types of computers like personal computers, supercomputers, supercomputers, embedded computers. Okay, that's what I showed. Okay, so then I have so I will ask some questions. So I mentioned that everyone wants better computers. So which means that we want purchase faster, right? We want run our applications faster in our computer systems, right? Then I mentioned that a processor, a processor execute instructions, right? And then actually our software is composed of many instructions, right? So then fast processor. Fast processor means, this processor can execute instructions quickly, more quickly, right? To understand? Then, which processor is better? Which processor is faster? It's a Pentium for 1.3 gigahertz, and then this is a processor on Raspberry Pi 3B, and then clock speed is 1.2 gigahertz. So can you guess? Do we have enough information for measuring the performance? So I mentioned performance, okay, for measuring performance of these computer systems? No, why? I just provide the clock speed, clock frequency. And then, if you are interested in computer hardware, then you can understand, using this clock frequency, then we can just measure the performance of computer system. So it means if the clock frequency is higher, then you can think, this processor is better. We typically think like this, right? So, the Pentium 4, and the clock frequency is 1.3 gigahertz, and then Raspberry Pi, the clock speed is 1.2 gigahertz. So, which is better? We don't know, actually, because we do not have enough information. Okay, so we will learn how to measure the performance later. And then, okay, So which processor is better and why? So this is the Intel Xeon processor. It's an Intel server CPU. And then this is the Intel i7 processor. It's a CPU for personal use. So which is better? It's for server, and then this is for PC, personal computers. So obviously, we can think that, oh, this processor is Intel Xeon. Intel Xeon processor is better. It's more expensive, much more expensive than Intel i7 processor. Then why? How can you measure? How can you measure the performance for the Intel Xeon between Intel Xeon and Intel i7? So we will learn, but you know, this is used for server, and then actually Intel Xeon includes more cores, number of cores. Okay, number of cores is different. And we will learn how how this number of cores make difference in performance. And then which processor is better? Intel Xeon and then NVIDIA Tesla, the GPU. You know, this is GPU. We already know that GPUs are more expensive. And then, as I mentioned, GPUs are more popular these days. But which is better? Actually, so the target is different. This is a CPU, and then this is GPU. And then design policy is also different. So for a certain domain of applications, GPUs are better, such as AI applications. For AI application, GPUs are better, obviously, right? But for the different kinds of applications, the performance of a CPU can be better, obviously. So you can understand. So actually, domains are different. The target domains are different between CPUs and GPUs. Okay? So we cannot say which processor is better simply in this question. Okay, so actually, performance is very critical. So this is because everyone wants to buy better computer systems, and then better computer systems represent faster. So which means this process, this computer system can execute our applications. And then I mentioned that an application is a group of instructions. So which means better computer system can execute many instructions more quickly. Okay, but there are many factors that can determine the performance of computer systems. You can find the algorithm, and then programming languages, compiler, architecture, processor and memory system, this is hardware part, and then I/O system such as operating systems. So it is because a single computer system is composed of many different components or layers. And then these layers determine the performance of computer systems. Like the algorithm is the software part, right? It's a software part. If we just use better algorithm, then you can increase the performance of our application. This is also important. That's why the algorithm is also very important course in this department, right? So algorithm is also mandatory course, right? And then programming language like C or Python, which is better? Python is easy to learn, but much slower. If we just compare the performance of programming languages, C is much faster than Python, because it's just totally different languages. Python is an interpret-based languages, and then C is the compiler-based language. Totally different. Programming languages also determine the performance of our system. Compiler and architecture. Compiler also decides the performance. So that's why the compiler is also the very important course. Okay. And then architecture. Architecture includes the instruction set architecture, the software and hardware interface. And then hardware, obviously. The hardware also decides the overall performance of a computer system. It's also important. Okay. And then operating system or IO devices. So our applications run on operating system, right? So that's why the operating system is also important. So actually, so in the sophomore year, so you will learn about the computer architecture and then operating system. In the junior year, then you will learn about the operating system and then compiler, right? So those are very important courses. Okay, what I need to learn. So actually, computer architecture is required for understanding our computer system. Okay, it's a basic course. So for better computers, in order to make a better computer system, it means the better computer system exhibit the higher performance and then lower energy cost. Okay, so you can just understand about some better computer system. Higher performance is higher, and then also cost is important, the lower energy cost. So those are two major factors for designing computer hardware, right? But then is it only required for hardware engineers? Actually not. So in order to make better software design, then we need to understand about the computer hardware. Also, recently, domain-specific software is very critical. For example, AI applications, right? So we can run our AI applications on GPU, but I mentioned that a GPU is totally different from the structure of CPU, which means in order to learn our AI applications efficiently, then we need to understand about the hardware architecture of GPU. So for domain-specific software engineers need to understand about the target hardware. It's critical. It's very critical for the performance of our application. And then hardware software co-design is also very important. So computer architecture knowledge is also necessary for software engineers. Okay. Okay, so what is done? Okay, here. So I already explained. So I'll stop here, and then in the next class we will learn about those the very basic concept in computer systems. Any questions? Okay. Thank you for your attention, and then see you in the next class. 감사합니다.